Hey there, and welcome to a quick video on limits at infinity and asymptotes for your calculus course. Let's just go ahead and take a look at a quick review here of how to find vertical and horizontal asymptotes when looking at a function. Some of you might be more visual learners first, so you might graph it first. So let's take a look at what the graph looks like. Okay, so here's a pretty good picture where we can see our function f of x in a decent window here. And when we're looking at vertical asymptotes, we're really looking for something like right here where x equals -3, for example. You can see that as x approaches -3 from one side, where our graph is down here at -infinity, and as x approaches -3 from the right, you're up here at +infinity. Those might be some things you talk about in your calculus course, but hopefully you can see that there's this vertical asymptote, sort of imaginary here, in your graph at x equals -3 and as well at x equals +3. And then in terms of horizontal asymptotes, hopefully you can see now you're looking for the end behavior of the graph, or in other words, your leftmost arrow and your rightmost arrow of the graph, and you can see that this graph does appear to be leveling off at 0. So we can algebraically look at that as well. You can also use your table of values to see that as x gets really, really large, or as you look to x being close to 1,000, 1 million, or however large you want to go, your y value will get close to 0. Same thing is true as x approaches something like -1 million. Your y value is approaching 0 as well. So these end behaviors, which is a term that you should be familiar with, of your graph seems to be 0. So let's prove this algebraically, or take a look at this algebraically and see if we can figure out why. The horizontal asymptote, you're going to learn this in terms of limits in your calculus course, but really this is looking at end behavior. So as x approaches -infinity, where is your function going? And again, that arrow here means approaches. So as x approaches -infinity, f of x approaches what? And as x approaches +infinity, f of x approaches what? And both of these answers for that graph was 0. And that's because if you put infinity into this function in for x, this +1 is really not going to determine the end behavior of it, neither is that -9. And so if you look at what is left in terms of powers, your degree of your denominator is greater than your degree in your numerator, so you might have learned that that meant y equals 0. So both of those horizontal asymptotes are the horizontal line, y equals 0. Okay, let's talk vertical asymptotes. One way to find vertical asymptotes, again, I'm going to look at the original function from the beginning here, and one way to talk about vertical asymptotes is by setting my denominator equal to 0. And so hopefully we can easily solve this to see that we get two answers, positive and -3, and we do verify on the graph that both of those equations of lines, x equals -3 and x equals +3, were the vertical lines that appeared to be those vertical asymptotes. Now, one thing that you might be asked to do in a calculus course, for example, is to evaluate. So for example, if I evaluate f of -3 and I put -3 in for x into my function, 5 times -3 is -15, and -3 quantity squared is 9. I know my denominator is 0, but you see your numerator is -14. This will sort of help you identify in the long run that that might be a vertical asymptote and not something else like a hole. And I could do the same thing with f of 3 and say that that's 5 times 3, which is 15, plus 1, over 3 squared, which is 9. Again, I knew the denominator was 0. 15 plus 1 is 16. 16 divided by 0 is undefined, so that is most likely a vertical asymptote. And we saw that graphically. Okay, so if you'll notice number 2 here, the only thing that I have changed is that now this is 5x squared. So let's go ahead and take a look at that graph. Okay, so let's take a look at this graph. Now, some parts of the graph might look familiar. For example, x equals -3 does maybe appear to be this vertical asymptote still, x equaling positive 3, let me follow that up, might also appear to be that vertical asymptote. And the farther you zoom out, the more you would actually see that it does mirror x equaling 3 as you get closer and closer to 3. So like if x is 3.0001, your y value is going to be very, very close to positive infinity right there. So that appears to be the case, but what you should notice is that my horizontal asymptote has changed. Remember, horizontal asymptotes are end behavior, where as you look as x approaches negative infinity, so way over here to the left, it appears to be leveling off at a value not 0. And so we can kind of zoom in and see, well, gosh, maybe that's a 5. And then as x approaches infinity to the right, it appears also to be leveling off at positive 5. Now, x equals 40 is nowhere near infinity. If you're looking graphically, but see, this is sort of hard to see, but you can see that it is leveling off. It kind of just looks like it made all the axes here a little bit redder, and that it's mirroring those axes, but if you zoom in, you can see that it's not. It's actually up here, y equals 5. So let's look at y. Well, we said that if x is approaching negative infinity, or as x approaches negative infinity, f of x is approaching something, and as x approaches positive infinity, f of x is approaching something. So let's take a look at what those somethings are. Now, when it's polynomial like this divided by a polynomial, as x is infinitely large, we're squaring it, multiplying it by 5, this plus 1 really isn't going to impact it all that much. Same thing with subtracting 9 from an infinity or negative infinity squared. So really now what you can see is you have 5x squared divided by x squared. So maybe now you can see why both of these simplifies to 5. So my horizontal asymptote for both would be y equals 5. So as x approaches positive infinity, your y equals 5. And as x approaches negative infinity, you're at y equals 5. You might learn other techniques. For example, you might have seen where you divide through by x squared over x squared. This is your function. And then you can see that you have 5 plus 1 over x squared, 1 minus 9 over x squared. I know this might look a little bit more complicated, but maybe now this gives you a little bit better reason of why. If x is approaching positive infinity or negative infinity, when you put those in here, when you square it, you're ending up with something positive, whether you're squaring negative infinity or positive infinity. 1 over infinity, or 1 over something really, really, really big, is going to approach 0. And so 5 plus 0 is 5. And 1 minus, same thing here, 1 minus 0 is 1. And so that's where I can see my y equals 5. So there's some different ways to look at this algebraically. So let's look now at vertical asymptote. Again, I have the same idea in mind. I'm going to start with where does my denominator equal 0. And so we said before we get two answers, plus or minus 3. So I have x equals negative 3 and x equals positive 3 is what I think are my vertical asymptotes. We did see those graphically to be the case, so I do know that they are correct. But if I wanted to evaluate f of negative 3, for example, so if I put negative 3 in for x into my original function, I get negative 3 quantity squared is 9. 9 times 5, 45 plus 1 is 46 over 9 minus 9 was 0. So again, I know that 46 divided by 0 is undefined, and I could do the same thing for f of 3, and that should also be 46 over 0 and also undefined. So I do have a horizontal asymptote and two vertical asymptotes on this one as well. I hope you found this review of vertical and horizontal asymptotes helpful as you go into your calculus discussions. Thanks for watching.